Today we are diving into the amazing world of React, one of the most popular JavaScript libraries for building dynamic user interfaces. Whether you've just heard of React or you're looking to solidify your skills, this crash course is for you. React powers some of the most dynamic websites and applications out there, from Facebook and Instagram, but here's the good news. It's not as intimidating as it looks. And by the end of this video, you'll be well on your way to building some awesome web apps using React. Now what can you expect from this video? We are not just going to talk about theory, we are going to get our hands dirty by building a fully functional to-do app. A simple project, but packed with all the core concepts you need to know to become comfortable with React. Here is what we'll be covering. What is React? Why is it so powerful and why should you learn it? The core concepts of React, like components, JSX state and props, event handling. We'll show you how to make your app interactive. React hooks. You'll learn how to use the UseState and the UseEffect hook effectively to manage data and side effects. Rendering lists, like our task list, and persisting data, because we'll be saving the data to our local storage so that even if you reload the page, your tasks will be saved. By the end of this video, you'll not only understand these key concepts, but you have built your very own to-do app, one that you can expand upon, style, and make your own. And trust me, once you understand React's building blocks, you'll be amazed at how fast you can create dynamic web applications. So if you're ready to start building with React, stick around, be sure to grab some coffee, fire up your code editor, and let's dive right into React. This to-do list is going to be a little different from the normal ones, because here you can obviously add the tasks that you prefer, but you can also archive them, delete them, or filter them by priority, their deadline, or by completion. And of course you can also edit them. And other than that, to showcase routing, we'll also be implementing another page, which is going to be a dashboard using ChartJS, where we show a distribution of our current tasks by their priority. I hope you're excited about this, so let's get started. Alright, so let's tackle the first question. What is React and why should you use it? Overall, React is just a JavaScript library. It's not a framework. Some of you will refer to it as a framework. A framework is something that has built-in functionality that covers all the needs of a web app. I would say React is a library because you can freely add and remove packages so that you can make your project more colorful. And the power of React is that it's component-based. You can create components which then later you can use up in other projects. For example, project 1 or project 2, the same component can be used again. And this reusability is really great because it keeps your code clean even while in the application, and it will help you with rendering your components. And to answer the question of why should you use it, well, simply because the largest companies like Meta use this. And if you want to get a job in this industry, then React is a pretty good way to start. As a matter of fact, React was invented by Meta. So this was just a quick breeze through of why you should use React. Obviously, you'll see the power of it when we get started with it. So let's jump to the installation. How are we going to install React? First of all, we'll be using Node.js. Node is needed to install packages with the Node Package Manager. When using most of the frameworks, you'll be needing Node to run your application. We'll be connecting this with Vite. Vite is a modern and very fast tool for creating web applications, so we'll be creating our React app with Vite, and then your app will be ready for the usage. For the installation, I won't be going through with you how to install Node. It's pretty straightforward. Just go to nodejs.org, and then in the Downloads tab you can, I believe it's easy to install it with a pre-built installer. So for example, you can choose for Windows, Mac OS or Linux. You just simply click the Download Node.js button and then go through the installation process. As for Vite, you have nothing to do about it. When we use the Node Package Manager, it will know that we will be referring to the Vite to build our application. So it's just something that I wanted to show you. Here is their website if you want to know more about it. They have this cool animation over here. And that's about it. Now let's jump to creating our project. I've opened up Visual Studio Code. As you can see, I have a folder open where I'd like to create my project. And then I click the dots here, terminal, and open a new terminal. The way you create a React project with Vite is by typing npm, which comes pre-installed with Node.js, create Vite at latest. Hit enter. It will ask you to install some packages for Vite, so you have to proceed with yes. Now you have to give the project name. Give whatever you'd like. Then we proceed. And here you will be asked to select a framework. Obviously, we'll be using React, but if you heard, for example, of Svelte or Vue, later on you can try these out. For now, just go with React. Next, it will ask us whether we'd like to use TypeScript or not. TypeScript is something of a helper language for React and for web applications, so that it constrains you a little bit. It makes types mandatory. It's something that all companies use, but for now we'll be going with JavaScript because we need to learn React first before we learn anything about TypeScript. Our folder has been created and it's asking us to run these commands. For now, I won't be running these commands. I'll just go to File, Open Folder, and open our folder that was created for us. Now inside this folder we have a bunch of stuff. Don't worry about it yet. We are not finished with the terminal. So open up a terminal again. And this time I'll give the command npm install, or npm-i for a shorthand version of it. Npm install will make sure that you install all the dependencies and packages that you need for running a React application, or later when we'll be adding some other packages. If you clone a repo, for example, you'll always have to give npm install, otherwise Node won't find the packages that you have installed for the project and it will just keep throwing you errors. Okay, now that that's done, the third command that it was suggesting us to use was the npm run dev, as we are running the development server. So let's just do that and then we'll have a look at this file structure. Now when you do this, a local web server will be launched at the port 5173 by holding down Ctrl or Command on Mac. Click this link and you will be presented with your application. And if you open that link, you'll see that the Vite plus React application is working. There's a little button that you can click and it will count. This is with the UseState hook. Don't worry about it, we'll have a look at it. It's just a simple boilerplate you get so that you know that you've successfully created your project. Alright, so now let's have a talk about the folder structure that we have. First of all, node modules. You won't be using this. This is the dependencies and the node packages that you've installed. Don't touch it, don't worry about it. The public folder. The public folder contains static assets that are not touched by Vite, so they are not improved in performance by Vite. Usually you won't touch this one either. The source folder is something that you'll be needing and spending most of your time in, so that's important and we'll have a look at it in a minute. The git ignore file is basically, if you're using Git like I do, it makes sure not to push, for example, the node modules and the dependencies up to your GitHub repo and make it bloated. But for the most part, don't worry about it. Don't touch the ESLint config. Usually don't touch the index.html and just don't touch any of this unless you have a very good reason to. So let's open up this source folder. In this folder, we have a bunch of JSX files and we'll talk about what JSX is, some CSS files and the assets folder. The assets folder contains the SVG, I believe it's a favicon. You'll be needing to put your images in this asset folder. Let's start with the Main.jsx. I'll hide this step for now. Maybe if I zoom in a little more, you'll see it clearer. The Main.jsx is basically your application and what's displayed in your application. It's the root, so usually you don't want to mess around with it. There you can see a bunch of import statements here and some HTML-like elements, and that's because it's a JSX file. JSX means it's both JavaScript and HTML. It just acts like HTML because React uses something called a virtual DOM, and JavaScript will render your page for you. It's not HTML, it's dynamically injected HTML, which has its drawbacks in CEO, for example, but it's pretty good and dynamic and usable after all. What you have to take away from here is that these import statements are grabbed with relative paths from your files. Strict mode will go away when you build your application. It's only in the development mode so that it checks twice and it's ultra bulletproof, so you can't make, for example, infinite loops and stuff like that. The create root is what's going to render whatever is inside in here. This time it's the strict mode element wrapped in the app element. You are also importing the app element. App is a simple component. This is how a component looks like. It's usually highlighted with green unless you have something other than the default highlighter. So all this is saying is render whatever's inside the app. And then we are also importing an index.css here. There is CSS in React, of course, and we are importing all the stylings into the Main.jsx from the index.css. And the way these work with component structure is that if you import a CSS at the top level, that CSS will get inherited down to the bottom. So whatever is inside the index.css will apply to the app.jsx element, which is what you saw on the screen. This is our boilerplate, but we'll have a look at it in a minute. You tell the main that you should render the app, and you usually shouldn't change this. It's good this way. You can change the CSS. For example, I will be deleting all of this now. I will be doing the same with the app.css. And in the app.jsx, you see a bunch of stuff here. These are again some import statements. You are importing the CSS and all that. Press Ctrl A and delete all that. We'll be creating our own. Maybe this was a little too fast, don't worry. What I'll be doing here is calling refc. This probably won't work for you. This is how you create your basic structure for a new component. And the reason it won't work for you is because you have to come to the extensions tab and here search for ES7 React snippets. The one I have downloaded is this one. This will implement some snippets to your application, for example refc, and that way it will make development life much easier. So now that I've changed whatever is inside the app.jsx, which is obviously what's rendered in our website, what I'd like you to do is change this div to be an h1 here and type in whatever you'd like, for example hello world, and then go back to your application. So now what we've typed there is displayed in our application. Whatever you type there will get displayed. That's because in our main.jsx we are rendering the app, and then inside the app component we tell it to render this h1 hello world. This is where you insert your content, what you'd like to see. You can change this to whatever you'd like to write in here, but something to note is that if I create a p tag here, call lorem inside, which obviously gives us a whole bunch of text, we are getting errors. What does this error say? It says JSX expressions must have at least one parent element. That's because I cannot render multiple elements while they are on the same level. If I wanted to render this and just cut this off, I would have to render it in either a div and then do it inside that, or something called a fragment. A fragment is just basically an element like this, and I can paste inside my elements. That's because a fragment will hold together my elements, and then multiple elements of the same level can be rendered. It's just something React implemented this way, and that's how it works. So now if we come back to our site, more HTML elements are rendered. I hope that's clear. This is how rendering works in React. And now what I'd like to do is insert some CSS into our application. Obviously, our main component, our root component, has the ./index.css imported, which means all the styles that I put into the index.css will get inherited down into the app.jsx. But for now, we'll be opening up the source code of this project, which you will be able to access from our GitHub repo, and I'll be showing you how to copy-paste the CSS from there. So if you open up the link, this is something that you should be seeing. We have the public, the source, and all the other files that were created when we created our project. So I go into the source folder, look for the index.css, open this up, and then just simply copy whatever is inside this. And I can freely paste this into our index.css. Now if we come back to our application, the colors changed, so our CSS is applying. And for now, for this project, I won't be touching the app.css, you might as well delete it, but I'll just leave it there for now. What I'd like to do now is come to our source folder and create a new folder inside that called pages. Inside that we'll be creating our first component. Well, it's going to be more of a page that contains other components, but it's basically a component. And we'll be creating a new file in here called home.jsx, creating its pair, which will be home.css. And first we'll create the elements for the home.jsx, and then we'll move on with implementing the CSS for that component. Okay, so to implement our home.jsx component, call refc. I hope you've installed the extension, otherwise you'd have to copy this by hand. This creates us our div, but I don't want our div here. Instead, I'd like something else. For this, I inserted some HTML code. This is nothing but a div, a title, and then inside that, these are the filters. Now, if we come back to our app, this won't be visible. We are still seeing the app.jsx displayed. And to make it visible, I'll come to our app.jsx and here display the home page. I start with angled brackets and start typing home. Now, there is a path from where it will import it because the IDE helps me out, and I can import this just like I would as an HTML element, because this now functions as a component. So whatever is inside this home as the HTML and all the functionality will get rendered into the app. And guess where the app is rendered? The app is rendered in our root, which is displayed to our website. So if I save this now and check on our project, there is our HTML rendered. Obviously, it looks ugly because there is no CSS implemented into it. So to implement CSS, come back to the home.css, come to our GitHub repo. I'm inside already the pages folder, come to the home.css and just grab the code from here. Now that you've pasted that in, this is just some basic HTML. You can have a look at it, it doesn't matter. In the current state, if we come back to our app, it's still not applied. That's because we didn't import it like we did for the app.css and the index.css. So come back to our home.jsx and type import, then quotes and ./home.css. Now the CSS that we've written in the CSS file will get imported and applied to all these elements that this component is rendering. Have a look at the project now, and it's all styled and neat. That's super, but this is the filtering of our part, and for us to filter something, first we'll have to add elements. Second, we'll have to list those elements. I'd like to tackle the adding of elements first. We'll be creating a component here, and that component will be called taskform.jsx. In fact, in the source folder, it's good practice to create a folder for your components, and then inside that, create a new file, taskform.jsx. For this one, we won't be pairing it with CSS because it's already inheriting from the home.css, but if you want a reusable component, of course you need to link it with a CSS. For this crash course, all this CSS is incorporated into the home.css basically. I call refc here. I've now injected some HTML here as well, and in this part you learn how to use the UseState hook and how to handle events and work with forms. Obviously, you won't see this in the application yet, so let's apply it. I'll call the task form over here, just like I would an HTML element, and the IDE helps me out by importing the task form from our files. If you have a look at the project, there is the task form. I can check whether it should be completed or not, its priority, its deadline, and its description, and I can then add it, but this is not functional yet. Now, how do we go about making it functional? How would you go about making it functional with simple JavaScript? You'd need variables to store whatever's put inside and selected in these input fields, and then you'd handle the submit with some functionality. To go about this, when you write JavaScript in JSX, you always write it above the return statement, and you can simply create variables like here, like variable 1 equals and whatever you put in there, and you can do it for variable 2. But this is not really the way we are going to go about it, because React won't recognize these as something that if they change, this should re-render the component. For that comes what we call hooks. Hooks are basically functions that let you hook into the core features of React. And the first one we'll be having a look at is the UseState hook. This UseState hook has to be imported. The IDE helped me out when I typed here UseState and then pressed enter. It has to be imported from React. And what this UseState hook does is it creates basically a variable that if the value of that variable changes, it will tell React that, hey, this value changed, we should re-render this component. The usage of this is that when you call UseState, you can give a default value. I can give strings here, true here, a number here, whatever we'd like for it to be. For now, I put strings here because I'd like the first variable to be the title or the description. And then you won't be able to use this in such a form. You have to store this in a variable. Usually we store it in a constant variable, but then you might be asking, hey, Didn't you just say that the value needs to change for React to do something to re-render the component? Then why are we putting it in a constant variable which cannot change? Well, that's because we are not creating a simple variable here. This UseState returns an array. And this array has two elements. The first element, you can name it obviously whatever you'd like. I call it description for now. The first element is going to be the value, the getter method of the UseState. And the second will be usually what we annotate with set, and then the name we give in the first one, set description. The set description will be a function for setting the description. So if I was to say description equals and whatever inside here, this wouldn't re-render React. In fact, it wouldn't even take effect. Because how you go about setting a UseState like this is by calling the set description function and then inside pass whatever you'd like. And this will signal to the React that the value changed and it will re-render the component. Now, how do we link this with our input elements? First of all, each input element has something called a value. And this value can be linked to something if you set it with curly braces. And I link it to the description. That means that I set the value of the input to be whatever's the description. But we need a two-way linking. And just a little side note here that I forgot to mention about JSX files. If you've seen the class name instead of the class, JSX has modified values for these. The class simply won't work, you'll get warnings from your editor. We use class name. It works the same as the class. It's just class name instead of class. So with this little detour, let's try this out. We set the value of the input field to be the description. I set the value to be first task by default. And let's see what that does. You can see that in our to-do list, the first task got implemented into our input field, but I cannot change it. It's just not changeable. Even if I try to delete it, React won't re-render for us. And to solve that issue, there is an onChange event on the input fields that you can utilize, where you can pass in an arrow function. And just like you would in simple HTML and JavaScript, this arrow function receives an event object, which I will refer to as E, and onChange, whatever is inside this will get executed. So obviously you would set the description to be the e.target.value as of the value of the input field, but that wouldn't work. I already told you, even if you try it out, it won't work. What you need to do is call set description and then e.target.value. Now if we come back to our app and I can change this and the description value changes, because obviously if it didn't, we wouldn't be able to change the input field, just like we weren't able to the last time we didn't implement this. So that's working, that's great. We can work with input fields. You can also console log this out in the onChange function if you prefer. Let's move on to binding up the other values as well. Let's go with the date for now. Let's bind up our deadline. And I will store this deadline in a string, and we'll be using the UseState for that. So I call it deadline, and then obviously its pair comes set deadline. And this will be equal to the UseState function, which will be an empty string by default. And I will also remove the first task from here, because I do not want anything to be implemented when the user opens up the app. I just want it to be an empty string. And in the date, we can do the same as we did before. We bind the value to be the deadline. And on the onChange, shorter-hand syntax is by calling the E and then not opening curly braces, but simply passing in the set deadline and then e.target.value. This way, we can change the date from our app and it will be functional. Let's do the same for the priority. Const priority, because I know what it will be called, set priority, and then this will be equal to another UseState, but this time I give a default value which will be low. And then in the select, I can chain it up with the value. This will chain up to the priority, and onChange, I'll pass in a function with the E inside it, the event inside it, and set priority will be equal to the e.target.value. just like you would do this in JavaScript. Let's do this one more time for the completed. It will be called completed, set completed, and then UseState, and I will put this at false by default. For the checkbox, we'll set the checked value to be equal to the completed, and then on change, we pass in the event function and call set completed with the e.target.checked. With this, we can change around the values of the form, but we still need to handle the submission and how we add an item. To handle the submission in our form, there is something called an onSubmit event, and we can pass in a function there. But to keep our code clean, I'll create this function as a const handle submit function, which will be an arrow function passed in here. It will receive the event object. The reason it will receive the event object is because I will have to call e.prevent default, because if we submit something, then only the page would refresh. This is from basic HTML, and we want to prevent the default behavior of the form submission. And not only that, but I'd like to create a new constant object here called new task. And this new task will have an ID, because we'll be having to distinguish them and delete them and add new items. And the ID for the newly created item will be the date.now function. In the meanwhile, let's pass in the handle submit over here because it's throwing me errors. And then as for the other properties of the new task, I just say description, deadline, priority, and completed over here. These will be values in the object. And to test it out, I will console log out the new task. Let's jump back to our application and test this out. Let's say I want to add the first task. I'll choose a deadline for it, for example 5, and I put a medium priority on it. Open up the development tools, and here I'll just submit the task. Now our object gets written out. Is complete is false, which is correct. The deadline is correct. The name is correct, and an ID is a timestamp that will never be the same because we can never go back in time for the same timestamp. And this priority is going to be medium. So our submission is working. Now we have to go to other components and create a list where we can then chain this component up and then render our already existing tasks. Now that we are done with our task form, I'd like to store what we create from our task form in some sort of variable and then display them in a list. For that, I'll create a new component called tasklist.jsx or fc, and then I'll insert some HTML into here. Here is the task list HTML that I've inserted. We'll be extending this with functionality later. For now, let's go back to our home.jsx, and above our last div, let's implement the task list. And if you have a look at our app, a dummy task appeared. You can enter. This will be for the editing part. It's not the best looking, but it will suffice. And we cannot really do anything about it. It's not functional, and it won't really be functional until we dynamically render all the tasks that we create. So how do we create more tasks in here? Obviously, I could come to the task list and copy this list element all over again, like this, and then again, and then again. And if you come back to our app, then more tasks appeared. But this is not something you really want to do. This is what you do in HTML, but we are working in React. So come on, let's use the dynamic rendering. I revert all of this copy pasting over here. And now you learn about props. Props are basically parameters, just like you would pass in a function that you can pass into other components. That's why components consist as an arrow function. Inside the parentheses, you can pass in a props holder, and then later you can refer to it as props.whatever you pass in as the name. But that's not how usually people do it because it's not clean code. The clean code version of this is by destructuring this object by putting here curly braces, and then for example, the first prop that this task list will receive is going to be a tasks object. So in here, I put a tasks object. This will be an array of objects, and then to dynamically render this, I can cut this list element from here, put curly braces inside our HTML and say tasks.map, just like we would use this in JavaScript as the map function. This usually returns an array in JavaScript, but now we'll return some HTML instead. Put another arrow function inside the map function, and then in parentheses, render your HTML. So I copy-pasted our HTML here in parentheses, and this map function receives an item, which I will for now call task, and then later we can refer to the properties of this object, which is pretty neat because then I can, for example, dynamically render the description of this. And to pass in the prop from here, we'll go to our home.jsx because that's where we implemented the task list. And the IDE will help me out. I can pass in something into these tasks. Now this tasks is going to be a UseState, because if the tasks array changes, then I'd like our app to re-render. So I create a new UseState here called tasks, and then set tasks, and this will be equal to a UseState, not useCallback, UseState. And inside that, for now, we don't have dynamic data that's coming from our saved cache in the website. So I just insert in an array, and then in the array, we'll put in some dummy data. For example, ID will be 1. The description will be first task dynamic. Then there will be a deadline. This deadline will be simply something in strings. Then I'll also insert completed, which will be false. And what else did we miss? We missed the priority, which will be set to medium, for example. This is a dummy data, which I will copy over once again for like 3 times. The ID needs to be different, so I say ID 2 and 3, and then a second and third dynamic data. Let's also set the priority to be high and low on the first one maybe. And now I can pass this tasks UseState as a prop into our task list. And let's have a look at our app now. Our app rendered 3 dummy data over here, 3 dummy tasks basically, but the data from which we've passed in is not yet implemented into the task list. To make sure we can implement this data, I'll come to our task list, and where we are mapping the data with the task function, I can set the input value for the description to be task.description. I can do the same for the date with the task.deadline. I can do the same with the priority, and the same for the checked with the task.completed. With this, our data should be implemented from the task that we are mapping. So each task will have the corresponding priority, description, and all that. So if we have a look in our app, there we go. First dynamic, second dynamic, and the priority also changes, and the third dynamic. There are some other changes too that I like to make for this to be fully functional. For example, changing the class name dynamically. To change the class name dynamically, you can see that we already have a task here in backticks. I can then put a $sign in here and check with the ternary operator whether task.completed is true, because if it is, then I simply put the completed class in the class name. Otherwise, I will simply put nothing there. This is how you dynamically edit class names and classes. This is very handy if you're working in Tailwind CSS, because then you have some sort of logic and you implement the built-in classes based on that. This is good, but we still need to implement a few things over here. For example, I cannot change the values inside those yet. We'll be handling the addition later. But if I have a look at our app and in the console, if I refresh, what you see is a bunch of errors. Now, the form is rendering. Why are we getting these errors? That's because there is something called a key in React when you're dynamically mapping that needs to be set so that React can distinguish the elements from each other. And so no errors are thrown like this. As it says, each child in a list should have a unique key prop. Let's jump back to our task list. And when we are mapping, the parent element should have a key. And this key will be the task.id. Because each task has a unique ID, React can use that ID to distinguish them using this key prop. This is built into React, so you always have to give it whether you're mapping with the filter function or the map function. Now if I refresh here, the error is gone, but it still says that I provided something of a value without an onChange. This means we won't be able to re-render. And that's something we saw when I introduced you to the UseState function. So we'll be handling the editing now. Now to handle the addition of our task lists and to make those errors go away, we have to pass in something to the onChange function so that they are hooked two ways. For that, I'll create a new function in our task list called const handle edit. This will be an arrow function, and as a prop, it will receive a task, a field, and a value. The task will be an ID, or at least which task are you going to edit. The field will be which field of the task are you going to edit, and the value will be what are you going to edit it to. As a constant variable, I create the updated task, which will be equal to a new object, and I'll use the spread operator over here, task. So we are copying all the values from the task into this updated task, but we are going to change the field attribute to be the value. And this actually won't work. I have to put a column here. And now, since the objects are stored in the parent element, we have to signal to the parent element that the task should be updated. Do something here. And to make this work, I'll chain up the onChange function just like we did with the other UseState in this description input field. And I'll pass in an arrow function. It will receive the event object and it will call the handle edit function. As for the task, it will receive the current iterations task, the one we've displayed over here. As for the field, it will be the description, obviously because we are setting the description input field over here. And as for the value, it will be e.target.value. And I can just copy this, paste it over to the other input field, but this time it will be deadline. Do it once more, this time with the priority, and the last time with the check, this time with the completed field value. This will make sure the onChange calls this handle edit function, but we still do not signal back to our parent element. So to signal back to our parent element, we have to create in the home an update task function. I'll create the function over here, update task will be equal to a new arrow function that receives a task. This will be the updated task. And all this is going to do is call the setTasks function. And what I'd like to update this whole task to be is the tasks.map. And on a condition, I'm passing the task here as just I would call this item or whatever. On a condition, I would like to decide which item to update. And that condition will be if the task.id is equal to the updated task.id, updated task.id, just like this. Then with the ternary operator, we'll map the updated task. Otherwise, we'll simply render the task that we are going over. If this isn't clear, all you have to take away from this is that we are going over all the tasks, and if we find the one that we'd like to update, then we put the updated version in there instead of the simple task that was there before. But we need to call this function somewhere. Where do we call it? Where, luckily, we created space in our task list to call this function. So I can pass this function down as a prop, and this is a concept in React called a callback function. You pass in a function that will get called somewhere else in the component on some other occasion. So in the task list, I'll add a new prop called update task, and I will call this update task over here with the updated task passed in. So we're passing in update task, just like this. I mistyped it. So we're passing in the updated task in the update task function, and it will eventually call this update task in the parent element because I will pass it in as a prop, update task, and we are passing in the function that will get called in the task list. When I was first learning about this, it was a bit tough to wrap my head around it. So what we are doing here is passing in a function from the parent element that gets called in the child element with the props passed in from the child element. That's all about it. Now let's check on our application. If I refresh, we no longer get those errors because we've chained up the UseState functions, and I can freely edit these now. I can edit the completed button, and actually there is something wrong with it, I believe, but the dynamic CSS is also working. Yes, and what was wrong with the checking of this checkbox is that we need to set the e.target.checked here instead of the value. And if we check on our app now, I can freely check this in and out. So the editing is working. Now we should be able to add tasks from our form. So to chain these up so that if we submit the form, the value from this form gets out to the parent component, which then changes, and then the list component will render the current tasks. Now first I'd like to start this in our home.jsx. Above our update task, I will create a very similar function called add task, and this will receive a task, and all it's going to do is call the set tasks function, and it will set it to an array with the spread operator that's already been set, so it copies the existing tasks over, and to the end of it I will put a comma here and insert a new one, the new task that we receive as a prop over here. That's all the add task function is doing. We are putting a new element to the end of our task list. Now that that's done, let's jump to our task form, because that's where we'll be implementing this. This new function that gets called will be received in the props, so I'll insert the add task function over there. And all we are going to do is, after we've initialized the new task in the submission, I'll call the add task and simply pass in the new task that we've created. That's all we are going to do. The last thing that needs to be done for this to be fully functional is that I need to set the prop, the add task prop here, which is waiting for us a function. I pass in the add task over here. That means whatever I now submit from that form will be added to our list. Checking on our application, I will add the new task over here, set its deadline to be, I don't know, 19th. It will be completed and it will be high priority, and I'll press the add task. The new task got added over there. It's all the properties I've given it. What's missing is that the form doesn't get reset as I submit the form, so I almost thought that this was some sort of error. And let's implement that in our task form now. So in our task form, after we've added the task, we need to reset with the setter function all these UseState values. For that, I just simply call the set description, set deadline, set priority, and set completed to be their basic values. So now if I come back to our app, I create a new task over here with task 2, set a deadline, set to be medium, add the task, the form gets reset, and the new task appears at the bottom. That's exactly what we wanted. Next, we'll work on the deletion of tasks and the archivation of tasks. Alright, so to work on the delete functionality, we need a function just like the add task in the home.jsx, where we remove a task instead. I create a function called remove task, and it will be an arrow function. This arrow function will receive the ID of the task that we'd like to remove, and we'll call the set tasks on it. And what it will be set to is the tasks.filter, meaning we are going over all the elements just like we would with the map function, but we are checking against a criteria. If that criteria is met, then we allow the item to be added into the filter. If it's not, then we don't add the item. I'll insert the task here, and if the task that we are currently iterating over .id is not equal to the ID that we've passed in, then we can safely add that item to our current tasks. Otherwise, the one that we want to remove won't be added back to our tasks. The same things applies as we did with the update task. We have a button in our task list in the element that has a delete button, and we need to trigger the deletion on the delete button. The implementation for this is going to be pretty simple. We have to pass in the function that we want to call. I'll call this remove task, and then we chain the onClick event for the button. And whenever this is clicked, we call the remove task function with the task.id. And this task, whenever we are referring to it, is always going to be the current task that we are mapping, and we are referring to their ID so that they are deleting themselves when the delete button is clicked. Now I'll come back to our task list in the home.jsx, and as for the remove task, we simply pass in the remove task. Let's try this out in our app. If I click these delete buttons, our tasks simply disappear. Do we get any errors? No, we don't. Then that's perfect. Let's see if I create a new one. Can we delete that? New one. Set it to be something, edit, and then delete it. We can totally delete it. So our delete functionality was pretty simple. It's done. Now we can maybe start working on archiving our tasks. For that we need a new component, because just like the task list does, I'd like to display the archived ones as well. So I'll create the archived tasks.jsx, and I mistyped it. Core fc over here, and then I'll insert some HTML yet again. For now, this is the HTML that I've inserted, because for this component to work, we need to pass in some data, and the data is going to be an array just like with the task list called archived tasks. And we will do the same thing that we did with the task list. In curly braces, I say the tasks.map. We are mapping them once again out into an HTML format, basically. The currently iterated item I will call task, and I will insert there a list element, and the key should be set to the task.id as we did before, because only this way will React distinguish the dynamically mapped items. And then inside this one, I will insert this because we don't have to type this out for now. We are referring to the properties of the task. It's the same properties. There is the description, the deadline, and the priority, and we are simply displaying those, and we are displaying if it is completed. Then we display completed, that's the text, and then if it's not completed but still archived, it will be incomplete. That's how this basic component should work, and below the task list, simply call archived tasks, and it will import it for me up there. But I need to pass in something into it for it to be functional. For that, let's create a new UseState just like we did with the tasks. I will simply copy this over, and instead of calling it task, call it archived tasks, and then set archived tasks. And we could leave the data just like this, because why not? It will still get displayed. It's just a dummy data. Later on we'll be dynamically creating these. So now let's just pass this in as a prop. Let's open our application, and if you scroll down, you can see the information displayed. That's perfect, that's exactly what we wanted. What I'd like to do is for this to be dynamic, so that I can archive these tasks, and they can then get displayed in this component over here. So instead of putting in dummy data there, I will leave this to be an empty array for now. And below our updating, remove, and all the other task functions, we'll create another function called archive task. This will be another arrow function, and it will receive an ID. Which task do you want to put into that archive list? First we have to find the corresponding task with the ID. Const task to archive will be equal to, as I said, we have to find it, so tasks.find, and we are looking for, here we pass in the task, because this iterates over all the elements, we're looking for the task that has the ID equal to the ID that we pass in. Once that's done, we can set the archive tasks to be a new array, spread the current archived tasks. This will copy over the current ones, and then we append a new one to the end of it with the tasks to archive. But that's not enough, because we can archive this way, but we still need to remove the task as well. And I pass in here the ID. This will remove it from our current list. And now to make this functional, of course, the same story as we did with the removing of the task. Go onto our task list, pass in a new function called archive task. And then when we click the archive button, we archive the task. And actually this should be an arrow function, call the function, and then pass in the task.id. It's that simple. Now we go back to our home.jsx and pass in the function archive task. That's it. Let's test our application. For now, this list is empty, but if I start clicking the archive buttons, they will start disappearing because obviously we are removing them, but before we remove them, we add them to the list below. That's working perfectly. Next, we'll move on to the filtering of our data. Now to start working on the filtering, this is going to be a bit more complicated, but it's nothing we can't tackle. So, below the archive tasks, I will create a new constant variable called filtered tasks. And we'll set this equal to the tasks.filter, and then inside here comes our logic. We will receive the task as the current iteration of the object, and we have 3 filters to check by. Whether it's complete or not, we can filter by its priority, low, medium or high, and whether it's in the deadline, do we have time for it, or has it already passed the deadline. For now, I'll only leave a comment here, filter here. But we need a UseState for this to store the data of our filter, so basically what we've set in those checkboxes. Below our other UseStates, we'll create a new UseState called filter and set filter. It will be equal to UseState, and then this will receive an object. The default value of this object is going to be what's presented by default in our filters. And those are these values: completed, all, priority, all, and deadline, null. If you check the app, these are the default settings. Let's chain these up first with the onChange event. In the completion, onChange, we call the setFilter function, and this will be set to a new object. I'll spread the current object, the filter, so we copy over all the existing values, and then set the completed value to be e.target.value. I copy this onChange function and paste it to the priority as well, but this time we set the priority. And I do the same for the deadline. This time we set the deadline. We've changed up the inputs with our UseState, and now we can start using this UseState and checking against it in the filtered task function, basically, in the filter function over here. So let's create a constant variable to check if we are filtering by completion. By completion will be equal to, we first check whether the filter is set to the all. So filter.completed equals all, because if it is, then we don't want to check any further. This will evaluate to true. Otherwise, if this evaluates to false, then we check if the task.completed value is equal to, and then another setting here, filter.completed equals true. The reason we are setting it like this is because if the filter is not set to be true, then it's probably false, because it's also not all, because then it would have evaluated to true. That means if the task.completed is either set to true or false, it will set the by completion accordingly. We will create a constant variable by priority. Again, we are checking if filter.priority is set to all, because if it is, then we don't want to check any further. Otherwise, we check if the task.priority is equal to the filter.priority, and these can be low, medium, or high. If the filter that we've currently set is the same as the current task we are going over, then this will evaluate to, I've actually pasted this in the wrong place. I have to put it over here. And as for the last one, we are checking by the deadline, const by deadline will be equal to if filter.deadline and not filter.deadline, then this means if the deadline is null, then we don't want to check anything. This just passes through and it will say display all the elements. Otherwise, we'll check if the new date, with the new date function, date, this is a constructor that receives the task.deadline, if it's less than or equal to the filter, or actually a new date again, new date, and then inside that filter.deadline. So if the deadline is not yet over, then we want to display the item. Otherwise, we don't want to display the item. And now at the end of it, we return by completion and by priority and by deadline. These are all bool values, which means each of them has to pass. If all of them are true, and by priority here as well, I mistyped this. If all of them evaluate to true, then the task can remain. But if any of them is false, then the current task cannot be displayed. And that's great, but we still need to apply this somewhere. Now, where will be the place where we apply it? We want to filter the task list, so obviously we'll be passing this down as a prop to our task list. Let's jump right there. And as you see, we already have a prop that we can utilize. The tasks are already mapped. So in this case, if we change the tasks which correspond to which element should be shown, then we should be able to evaluate this. That means if I come back to our home.jsx, I can switch these tasks to be the filtered tasks instead, which means if there are no filters set, it will still have the default functionality, but if we have filtering set, then it will override the default functionality and display only the corresponding items that are good for that certain filter that's set. So let's check on our app this way. Let's say I want all items with high priority. Then only the third task remains. Let's say I also want only the completed tasks. Then no tasks are involved. That's exactly how it should work. If I press the incomplete, then it's great. Let's see if I edit this, then it basically just disappears because I said I don't want only the incomplete tasks. Now I set this back to all. Let's test the deadline. What was the deadline for this? The 5th. So if I say 6, then all of them should be here. But if I say 4 as the deadline, none of them should be because they are already past the deadline where they were set. So these filterings are working exactly as they should. Next we'll talk about package installation and the usage of ChartJS a little bit because we'll be creating a separate component. So the next component I'd like to work on is going to be the dashboard page. This dashboard page will be needed so that we can learn about routing. I can show you how to route to that page, but it will also show you how to install the ChartJS packages and work with that. So in the pages, I'll create a dashboard.jsx component and I'll also create a dashboard.css file. So I've inserted some HTML into our dashboard.jsx and we also have the dashboard.css over here. I've imported it, although it's still empty. We can go to our GitHub repo, come back to pages, dashboard.css and copy all of this. With that done, we won't be able to see this component unless I deliberately say render the dashboard instead of the home page. Now we see that there's a little dashboard component. Now I came here to the ChartJS installation site. Here, if you just search npm install ChartJS in the net, you can probably find the proper command for it. And that's exactly the command that we'll be using. Copy this from over here, simply come back to your project. We already have a terminal open, remember, because despite we've hidden it, it's still here. Let's stop the development server with Ctrl+C, paste in the command, npm install ChartJS, run it, and then after it's done, we'll restart the server with npm run dev. Now that that's done, I'll hide this once again. And in the dashboard, we have few things that we need to import for ChartJS to be usable. These imports are the chart, the category style, the linear scale, bar element, all those you see up here. You need to import these and then you have to register a chart. This is in the ChartJS documentation where you pass in the category scale and the bar element and all these that we've imported over here. Next, for ChartJS to work, I'll also create a constant variable called data. And this will be a new object. And inside this object, we have to give the labels, which will be an array. It will be an array of strings saying high, medium, and low. These will be our priorities. We have something called the dataset, where the label is set to the task priority distribution. And then I put in some mock data here, 3, 4, 6, and the background color for each of the charts or the columns in our ChartJS data or what we want to display. And as for the next one, you can also copy paste these. These are just the usage of ChartJS, not really correlated to your React knowledge, but the options should be set to responsive true. And as for the plugins, we have a legend that's positioned on the top and the title, which is displayed with the text task priority distribution, the same as the label. Now we just have to import the bar from ChartJS. So we just import this bar from React ChartJS 2. And then in the bar, I have to pass in the data, which will obviously be the data we've set, and the options, which will be the options we've set. Let's get back to our app now and check this out. And our app is throwing us an error because we failed to resolve import. Now, these will be some things that you come across maybe when you are copy pasting code from the web or you're doing things like this. No worries. If we don't find the package that we're trying to import it from, we search for what's that package and then the npm version, and then you will see the npm install over here. I can say npm install React, ChartJS 2 and ChartJS. If I copy paste this, I'll open up our terminal once again, terminate our current run of the server, npm install this, and then restart the server. This should be working because the import then should be working. This is how you decide if one import is not found, then you probably need to import this where you're importing from, if it's a third-party package. So npm run dev. Obviously, the data we have in here is not yet dynamic. When we are able to save the data, we'll be setting this to be dynamic, but for now, that's all I wanted to do in this dashboard page. And we'll work on a navbar next and then have a look at routing so we can connect two pages, so it's not just a one-page app. As for the next step, let's install something called the React Router DOM. This is the official routing component for React. And if you search their website, there is something called guides. You press I'm new because it's an easy tutorial. And then here comes this setup. In this setup, you always need this npm install React Router DOM. I'll bring back our terminal, stop our development server, and then npm install React Router DOM. Now that that's done, I can also press npm run dev once again, close this up, and then move on to our Main.jsx. Because if you have a look at the documentation, it's guiding us to the Main.jsx. Copy these import statements from here, back to our project, import them at the top. Then copy this router element from here, back to our project, and paste it in. Then finally, copy the router provider, back to the project, and paste it in instead of the app. And now let's break down what this is doing. So we've installed a package called React Router DOM, and we are importing from that over here. We are importing the create browser router and the router provider. Then we are calling the create browser router and storing it in the router. What this does is it defines our routes, at which path, at which should we load. For example, I can say load the home page at the slash, and I can add another object in here, and path will be set to slash dashboard. And as for the element, load the dashboard component. The router provider is what tells the route to use this router that we've put in here, but we have to define it that we are passing this router in and these predefined routes, and this way it's just like we would be rendering our app, but instead, if we check on it, our server will reload. It's just like if we did with our app, and I can say slash dashboard, and it will make sure that the ChartJS side, the dashboard, is displayed, which means our components are now separated. That's great, but I'd like a navbar for the navigation and something called nesting with outlets in React Router DOM. That means the navbar will only be needed to be defined once, and then it will be available on all sites. For that, let's create in the components folder the navbar.jsx. And this is our basic navbar. You can see that I'm importing some CSS from over here. So I'll also create its pair, navbar.css, go back to our repo and search for the components folder and the navbar.css. Just copy this, bring it back to the CSS, paste it, and then we start working on the navbar.jsx. Now what I could do is in the home, before rendering anything, on the top I can render the navbar, and that should work if I wrap it in a fragment, but that's not quite what I want, because then I have to render the navbar on the top of each page, which is duplicating code. And to prevent that from happening, we'll utilize our app.jsx. Our app.jsx will be utilized by, instead of returning whatever in here, I wrap this in a fragment, I render our navbar, and then below that I render something called an outlet. This outlet will be a placeholder. Whatever the children has as its roots will be rendered over here, and it will make sense in a minute. So let's go back to our main.jsx, and I delete the dashboard path, and instead of displaying the home here, I display the app. And if we come back to our app now, we see nothing but this navbar. That's good for a start. And to make the other elements appear as well, I can say children. This will be a root object, just like the app object, and I can set a path in here, or actually not a root object, this will be an array of objects, and I can set a path over here, and this path will be the slash, and I will be rendering the element, the home element. So on the same level, if the URL is a slash, so basically the home page, then we render the app, that's for sure. And if it's still the slash, then we render the home. But I'll add another object. If there is a slash in it, which means we render the navbar, and it's slash dashboard instead of a simple slash, then I can say element and render the dashboard instead. Let's try out what this does. You can see that the home page is already here, it already appeared. If I click the dashboard, it routes us out to the dashboard. This navbar is working, but it's not quite how you expect it to be, because we are using an href. And if you pay attention over here to the refresh button, to reload this page, if I switch, it reloads the page, and that's not what React is for. React is made for one-page apps. That means we should re-render the components rather than refreshing the browser. That's what makes the site fast. So instead of doing this, I come to our navbar.jsx, and instead of using a elements, I import something from the React router DOM. This will be the link element. This link element is similar to the href elements, but instead of using href, we say to, and this to, if I leave empty, it will be equal to the slash, but we don't have to put a slash in here, just leave it empty for the default route. I do the same over here. Change this to be link, and over here as well, and the href will be set to 2, and I delete the slash from here so that it's just a dashboard. If we try this out now, without refreshing the page, the sites switch. So if you pay close attention to the refresh button, it doesn't refresh. And that's the built-in functionality of React Router DOM. That's how you should be using React Router DOM. Next, we'll go and have a look at the saving, so that we can get the data and display it properly in the dashboard instead of the smoke data. And also, if we refresh, the data will stay the same. Now, to start working on saving our data, first of all, we have to add it to our local storage when the task list and the archive tasks change. Now, to start working on the data, first of all, we have to save our data to a local storage. And for that, I'll be introducing you a new function, a new hook in React, and this will be the UseEffect hook. So in our home.jsx, below our UseState functions or hooks, call the UseEffect hook. What the UseEffect hook does is it executes some functionality whenever the component loads. So it will execute at least once, and then if you don't give it a dependency array, it will execute at every re-render and every load of the component. And if you think about it, this is not very good, because then we have an infinite loop. Because let's say we have something in our UseEffect that causes a UseState change, which causes a re-render, then we have an infinite loop. So to avoid that, there is the dependency array. But let's have a look at its syntax first. You pass in a function, and this function is what's going to get executed whenever the component loads. I can also console log out something over here. UseEffect called. And then as the second parameter, you can give the dependency array, but for now I won't be giving it. Instead, let's have a look at what this does in our console. As you see, UseEffect got called twice. The reason it got called twice is because strict mode is enabled while we are developing, and strict mode loads our components twice, so that no errors can occur, no unexpected behavior that would cause big problems in deployment. What if, when the component loads, I'd like to change the tasks, for example, just because they are a UseState? Then I can call the setTasks and set it to this element over here in an array. And let's save it and see what happens. As you can see, the console is spamming us with errors because UseEffect gets called an infinite amount of times. That's what we want to avoid. And to avoid this, we can come back to our UseEffect, and instead of the function is passed in, we can pass in a dependency array. Now, a dependency array means that whatever's inside this array will trigger a reload instead of always reloading after the component loads. This way, at its current implementation, this functionality will only run once. But if I put something in some value here in the dependency array, then if that value changes, then we execute the functionality once again. And if you check our application, if I refresh, then the errors are gone. UseEffect only got called twice again. I will remove the set tasks from here, and I will also remove the console log. And now we can implement functionality to load into our local storage. And to simply save into our local storage, I say localStorage.setItem, and we'll set an item with the key tasks and put in the JSON.stringify, use the big JSON like here, stringify, and we stringify the tasks as they are an array which can be passed into a JSON format, and this way our local storage can save it. Why are we implementing this in the UseEffect if it will only load once? Because when the uploads for a new user by default, no data will be saved, but as the user inputs more data, we'd like to save it continuously. And to implement that, we can put the tasks here as a dependency array so that whenever a new task is added or removed or edited, then we will override our current save in the local storage. Let's test this out by console logging the local storage.getItem, and we are getting the task. If I come back to our app, on load, the 3 items that I saved are here in a string format, which is obviously not too pretty, but this is how you save it. And if I remove a task, one less task is given there, the ID 1 is missing, and then one more, only the ID 3 is given there, and then an empty array is given because we've cleared our local storage. Let's delete the console log from here and copy this function because I'd like to save our archived tasks as well. And for this, I'll switch the tasks to be archived. Of course, change the stringify value as well, and change the dependency array as well. This way, the archived tasks will also be saved. And now all we have to do is somehow fetch this data from the local storage. Luckily for us, React Router will help us out and provide a loading feature that will allow us to fetch in the root component and then pass that loader down to other components so that they can fetch it themselves. For that, come back to the Main.jsx, and above our router, we'll create a new async function called taskloader. Const taskloader equals a new async arrow function, and we'll get the tasks from our local storage over here. Const stored tasks, make this equal to the JSON, the big JSON, dot parse, drop in here the local storage dot get item, and we are getting the tasks as we did before. Or if there are no saves in the local storage, we'll simply return an empty array. Let's copy this over and do the same for the archived, change up the values, and there we go. Now I return these values in a new object where the tasks value or key will be the stored tasks, and then the other element will be just passed in like this. And as I said, lucky for us, React Router DOM provides assistance for these loadings. There is something called a loader that you can set, and we'll set this loader at each the home and the dashboard as well to be the task loader. This will enable us to access this loader in both components. So let's move back to our home.jsx and fetch this data. At the top of our home function or home component, import useLoaderData from React Router DOM and call this function. And we can store this in an object with the names that we've given. For example, tasks, they will be set to initial tasks. This is the value where the output will go. And then I do the same for the archived. It will be called initial archived tasks. Now instead of putting in this dummy data over here, I'll just cut this out from both use states. Actually, the archived doesn't even have one. and I'll put the initial tasks in the first one and the initial archived in the second one. Let's check whether this works or not. As I see it, it already saved our data while we were working in the component. And if I start deleting this, we only have 2 items left now. I refresh and we still have 2 items. I delete all of the items, refresh, and we won't have any items added. So let's add some tasks. And if I refresh now, the task stays. Let's archive this. So we have archive tasks as well now. If I refresh, it also stays there. That means this fetching is fully functional for our home map. Now let's change the graph in our dashboard and fetch the data from our local storage. The implementation in the dashboard is going to be very simple. I store this with a variable named loaded data, and this will be equal to the use loader data, just like before. And here, instead of inputting dummy data, we have to count how many tasks we have with how many priorities. The way we are going to do it is by saying loaded data.tasks.filter, and as the sequence goes, we search for the high priority tasks at first. So we want to include tasks that have a priority set to be high. And we don't want to store this because this gives back an array. We want to get their length. And that's basically it. And now I can just copy this over a few more times and go for medium and low. And this way our data is going to be relevant to our real tasks that we've given, and it will dynamically update. If you test this in your application, the data is completely true. This is what we see because I've deleted everything the last time we were testing the application. So I can add some new tasks. And now that I've given here some values, if I check back in my dashboard, then we see that we have 2 high priority tasks, 1 medium and 1 low. With this, our application is fully functional. We can add data, edit data, delete data, archive our to-do items, and we can also save the data and make it persistent. If you've pushed through this, then pat yourself on the shoulder and take pride in it, because it was a longer project. The links for the downloads will be down in the description, as well as the source code and everything you need for this project. I hope you enjoyed it, and if you found value in it, please consider giving us a like, maybe even subscribe. And with that, I see you in the next one. Happy coding and God bless.